Hey, this is Horner, and this is the very last question on the DC circuit review. And this one is an actual AP problem from last year's test. So the thing we need to do is go through and do the best we can at trying to get as many points as possible. So to do that, let's just look at the circuit. Here we've got a circuit. Notice that it is a combination circuit. It has two resistors in series, and we have two resistors here in parallel. Don't start by doing a verb chart. There's no numbers here except for the 15 volts. So let's read it. Just says a student assembles a circuit, has four resistors. Let I1 be the current through resistor R1. So we know that this one is going to have a current I1. This one's going to be I2. This one's going to be I3. And this one's going to be I4. They want us to know that they rank the resistors. R4 is bigger than R3, which is bigger than R2, which is bigger than R1. So this one could be 4 ohms, 3 ohms, 2 ohms, 1 ohm. We don't really know what it is. We just know that this one's bigger than this one, which is bigger than this one, which is bigger than this one. They want us to rank the currents from in order from greatest to least. If any of them are the same, we need to indicate that. So this is a ranking task, and this is why we do a lot of those ranking tasks. If we look at this circuit and we think about the rules, we know that if we go around this circuit, every time we get to a junction, we need to make sure that that current is the same going into as it is coming out of. So I know that this is the negative side, but let's go ahead and say that we know that the current in I3 and I4 are the same. So that's something very easy. I'm just going to write down over here I3 is equal to I4. And it's because of the junction rule and because things in series have the same current. If these two have the same current, when it gets to letter A, I have current in I1 and I2. And both of these have to be less than what we have in I3 and I4 because notice there's a junction. So some of the current going this way and some of it going this way needs to equal what we had going in. So this one's definitely the biggest. So we can go ahead and put I3 is equal to I4, and that is greater than, now we need to pick which one of these two is going to be bigger. The resistance here is bigger, the resistance here is smaller. And if that's true, we also know that the voltage in each one is the same. Since the voltage is the same in each one, let's go ahead and make an equation for current. For the current in the first one, we know that's equal to the voltage divided by the resistance in the first resistor. And then we have I2 is equal to the voltage divided by the resistance in the second resistor. Because of the loop rule, remember both of these will have the same voltage, but they're going to have different currents. Let's go ahead and assume that this voltage and this voltage, since they're the same, we could call them both 1 if we wanted to. And then really we just need to look at the resistances. Since this resistance is bigger, this current is smaller. And so this current is going to be bigger than number 2. So now we have I1 is going to be bigger than I2. I2 is the smallest. Briefly explain your reasoning. So the best thing to do here is kind of talk through what I just did and write all that down. So in order to say this, we know first off that the current here is the same. So we can say by the junction rule, the current is the same in I3, which is equal to I4. The next thing we need to do is we need to talk about also because of the junction rule, both I1 and I2 need to be less than I3, which is equal to I4. At this point now we can say since I is equal to V over R, and because of the loop rule, V1 should be equal to V2, we can reason the larger R has less current, or less I. And then that way we can now say, at this point here, I'll draw an arrow up here. Anytime you need to continue on, if you put it somewhere else, just draw an arrow. They'll have to follow it. And because of that, since now we can say since R2 is greater than R1, the current in 1 has to be greater than the current. So let's do this. Has got to be greater than the current as soon as this refreshes here. Maybe it won't. We'll wait for a second. There we go. So the current in number 1 has got to be greater than the current in number 2 because of that relationship. So now you would end up with all of the points just for this part. And notice this is part A. Let's go ahead and take a look at part B. Part B is easier. So for part B, the student connects a separate voltmeter across each resistor. So now we know what the voltage is in each one. We're going to let the change in all these be the same thing. So we've got R4 is the change, the change in voltage, or change in potential of 4. This is change in potential of 3, change in potential of 2, and change in potential of number 1. Based on the measurements, determine the voltmeter readings at V2 and V3. So we have 15 volts here. We know that this one is equal to 9 volts, and they told us that V1 is equal to 1 volt. So right off the bat, I remember that R1 and R2 are the same. So this has got to be 1 volt. If these are both 1 volt and this is 15 volts, we have to drop 9 volts here. So when we take 15 minus 9, 15 minus 9 will give us 6. We also drop 1 volt for this entire thing. So we drop 1 more volt, and that gives us 5. Therefore, V3 has got to be 5 volts. Now they want us to explain why that is. So to do that, we're going to start with using the loop rule. We know that the change in V1 has got to be equal to the change in V2. And then just say since V2 is equal to, since V1, so we'll back this up, and it's a little bit slow again. Since V1 is equal to 1 volt, then V2 is equal to 1 volt. So here is our point, here's our evidence, and then there is our explanation. Next thing we need to do is explain why we got 5 for this one. Also, using the loop rule, we take the battery, which is 15 volts, minus the change in potential for number 4, which we know is 9 volts, and then we can take the change in potential for the parallel part of the circuit, which we know is 1 volt, and that is equal to 5 volts. And then you could say, therefore, the change in potential for the third resistor is equal to 5 volts. And now you would have all the points for letter B. One more thing that we need to do, and that is take a look at letter C. For letter C, it says the student now connects a wire from point A to point B. So if you take a wire and put it from here to here, what that does is it makes it so that nothing ever goes through R3. So we're going to cross that off. This is what we call a short circuit. A short, S-H-O-R-T, short circuit. And a short circuit means that we have just ran a wire from here to here. When you run that wire, it will never get to this resistor because it always goes through the path of least resistance, which is definitely this wire. When the wire is connected, does the current I1, so we want to know what I1 current and resistor R1 increase, decrease, or stay the same? So if you think about this, it should get bigger. And why is that? Why should it increase? And it should increase because the basically what you can do is we know that that makes the overall, so here we're going to say the overall resistance of the circuit, C-I-R-C-U-I-T, is less. Why is the overall resistance less? Because now I don't have R3 anymore. I only have R4, which goes into R2 and R1. So what that does for the circuit is now I only have 3 resistors. If I only have 3 resistors, my overall resistance in that circuit is less. And if we think about I is equal to V over R, if this is less, then the overall current is greater. If the overall current is greater in the entire circuit, it's greater in R4, it's got to be greater in R2, and greater in R1. So overall resistance of the circuit is less, therefore the overall current is greater because I know that current is equal to voltage over resistance. And since I made the overall resistance less, then that current has to be higher. Essentially, I just keep saying the same thing, I think. But that is the best reasoning that you would have for it, and you would get 1 point for this one by doing this. And then if we go back, you would get 2 points for the previous part. So we'll go back to the previous section here. Let's move down. This one you would end up with 2 points if you did everything we talked about for it. And then for the very first part, you would end up with 4 points. And those 4 points come from first the correct ranking, and then you had to explain for this that the resistors in the series have the same current. So we did that. You get a 3rd point for saying that I1 and I2 must be smaller than I3 and I4. And then finally you get another point for explaining why I1 is bigger than I2. So 7 points altogether on that one, and that's how you get those points.